Hi everyone, today let's see one of the important sum in differential calculus. The question given is f of x is equal to x to the power of 4 minus 2x square plus 3. What are the things we have to find out is, we have to find the critical points, increasing or decreasing interval, local maxima and minimum value and its points, concavity and inflection point. So let's start with finding the critical point. So first we will find the critical point. So before finding the critical point, what they have given f of x is equal to x to the power of 4 minus 2x square plus 3. So this is the given equation. For finding the critical point, first we have to differentiate this equation with respect to x. That is, we have to find f dash of x. If it is x to the power of 4, 4 will be coming down, x the power will be reduced by 1, 4x cube, minus this 2 will be coming down, and what is remaining is 2x. This power will be reduced by 1, so 2 minus 1 is 1, and differentiation of constant is 0. So what we have 4x cube minus 4x, this is 0. So we can equate this f dash x equal to 0. So now we have to find the critical points. How we have to find the critical point is nothing but the roots of the solution. You can just type this value directly in the equation and you can get the value, or you can simplify this. So what we can take common, we can take 4x as common. So from this x square will be remaining inside, and from this 4x is taken out, so only 1 will be remaining. So this is equal to 0. So what we have one equation, that is 4x is equal to 0. That implies x is equal to 0 by 4. So we got one equation, that is one root, that is x is equal to 0. And if another one is this one, x square minus 1 is equal to 0, this implies x square is equal to, if 1 comes this side, it will be 1. So ultimately we can write x will be equal to, can be plus 1 or it can be minus 1, because when we square root this, 1 square is also 1 and minus 1 square is also 1. So we have got the critical points. The critical points are x is equal to 0, 1 and minus 1 are the critical points. See, we can know from this equation. So we have x cube. So this x cube should have 3 roots. So we have 3 roots, that is 0, 1 and minus 1. These are the critical points. So next we have to find out the increasing or decreasing intervals. So increasing or decreasing intervals, so we have 3 values, 0, 1 and minus 1. The next thing we are going to find the increasing or decreasing interval. So normally we have values that is from minus infinity to infinity. We have the values of, this one will be minus infinity, this one will be of infinity. This is the total limit. And what are our critical points? That is 0, 1, minus 1. If you write in sequence, it will be minus 1, 0 and 1. So 0 will be in the center, we'll have minus 1 this side, and we have plus 1 this side. So before finding whether the interval is decreasing or increasing, we have to find how many intervals are there. So in this we have 1, 2, 3 and 4 intervals. We have to write, that is interval. So first interval is nothing but minus infinity to minus 1. So you can write it as minus infinity minus 1. So this is the first interval. So what we have to find out in this is, we have already found out what is f dash of x. F dash of x is nothing but 4x cube minus 4x. So from this interval we have to take any one value. So we'll take the least value so that we can solve easily. So minus 1 to minus infinity, we have minus 2 here. So we will take the value of minus 2. Now what we will do, we will substitute minus 2 in this equation. See what happens if we substitute minus 2 in that equation. We have 4 minus 2 cube minus 4 into minus 2. So minus 2 cube will be minus 8. So 4 into minus 8, and minus into minus will be plus. This will be plus 8. 8 fours are minus 32 plus 8. So it will be minus 24. So this f dash x will be minus 24. Now we have to check whether the interval is increasing or decreasing interval. See, since it is minus, the interval is decreasing interval. In the same fashion, take the next interval, that is minus 1 to 0. So what do we have to do? We have to take minus 1 to 0. So minus 1 to 0, what will be the next, what will be the point which will be very good for our calculation? That is minus half. So we can take it as minus half. So similar fashion, just substitute the value of minus half in the equation of f dash x. If we substitute minus half cube minus 4 into minus half, this will be 4, this will be minus 1 by 8, and this will be minus into minus plus 4 by 2. We can cancel it out, 1 and 2. Since the denominator is same, we can add it directly. That is plus 4 minus 1 by 2. So this will be plus 3 by 2. So what is the value of f dash x? This will be 3 by 2. Since it is positive, the interval will be increasing interval. In the same fashion, take another one, that is 0 to 1. So 0 to 1. So what value we can take? We can take it as half. We can substitute in this equation. If you substitute in this equation, we will be having plus, so 4 by 8 plus 4 by 8 and minus 4 by 2. We will have plus 4 by 8 and minus 4 by 2. And do it in the same way. So minus 4 plus 1, so minus 3 by 2. So this value will be minus 3 by 2. Since we have minus, the interval will be decreasing interval. So what is the final one? 1 to infinity. So final interval is 1 to infinity. So 1 to infinity, in the sense we can take the value, that is 2. So what happens if we substitute the 2? 2 cube is 8. 8 fours are 32. 32 minus 4 into 2, 8. That is 24. So it is plus 24. Since it is plus, the value is increasing. So we have found out whether it is increasing or decreasing interval. The first and third interval are decreasing interval, and the second and fourth are the increasing interval. Next we have to find the local maxima and minima. So next we have to find the local maxima and minima. So how to find the local maxima and minima is, we have to find f double dash of x. That is, we have to integrate that value twice. So already we have found out what is f dash of x. It was 4x cube minus 4x. If we are differentiating again, so 3 will be coming down, so 4 3s are 12. Power will be reduced by 1, so x square minus 4 differentiation of x will be 1. So this is f double dash of x. Now what we have to do, we have to substitute the critical point in this. So what was our critical point? The critical points are 0, 1, minus 1. So what we have to do, we have to substitute f double dash of 0. So this will be 12 into 0 will be 0, minus 4. This value will be minus 4. Since it is minus 4, this value is less than 0. If the value is less than 0, this will be local maxima. Okay. So at this point, we have local maxima. If you want to find what will be the value of local maxima, we have to substitute x is equal to 0 in the initial equation. What was our initial equation? Our initial equation was f of x, that is equal to x to the power of 4 minus 2x square plus 3. So is f of 0, because 0 is local maxima, we substitute 0 minus 0 plus 3. So this value will be 3. Next what we have to do, we have to check what about f double dash of 1. If we substitute 1 in this, 12 into 1 12, minus 4, that will be 8. So 8 is greater than 0. See, the point will be local minima. Let's check and see after substituting f of 1, that is equal to, if we substitute 1 in this, it will be 1 minus 1 square will be 1 into 2 will be 2 plus 3. So this will be equal to 2. 4 minus 2 is 2. So this is the local minima. Then we have to check for the third value, f double dash of minus 1. If we substitute minus 1 square, it will be 1. So 12 minus 4 will be 8. So 8 will be greater than 0. Then it will be local minima. Let's check the value of local minima, f of minus 1. So we substitute minus 1 to the power of 4. Since it is even, it will be positive, that is 1. Then minus 2 x square, in the sense minus 1 whole square. So this will become plus 1 and minus 2, and then we'll have plus 3. So 3 plus 1 4, minus 2 will be 2. Okay, so we have also find the local maxima and minima value and its point. So these are the points. 0 is the point for local maxima and the value is 3, and 1 and minus 1 are the points of local minima and the values are 2. So we have found out 3 things. That is, first they will give the equation f of x. We have to find the critical point. How we will find the critical point is differentiate this equation one time and we'll find the value of x. So that are the critical points. Next what we will do, we have to find whether the increasing or decreasing interval. We have minus infinity to infinity and other 3 critical points. We'll check how many intervals are there. We'll write all the intervals, take any one value between this interval, and we will substitute this value in f dash of x. If it is minus, it is decreasing. If it is plus, it is increasing. And third, we will again differentiate this equation, substitute the critical point. If the value will be less than 0, it is local maxima. If the value is greater than 0, it is local minima, and we will check what is the maximum value and what is the minimum value. Okay, so that's all for today. In the next video, we will see another 2, that is fourth and